MedShake.
Hi, I'm Anca, and this is the place to be to hear about the latest tech trends in healthcare. Let me ask you something. Have you ever heard someone say that quantum computers will change everything and thought, yeah, sure, but I still don't get what they are? Or maybe you break into hives at the words physics and quantum and wonder if quantum stuff is just for sci-fi nerds or Nobel Prize winners. Well, today I've got your back. We're going to make it simple, understandable, maybe even a little fun. Welcome into the Meta Health. So what is quantum computing? Let's break it down. Classical computers, the ones we all use, work using bits. Each bit is a tiny switch that can be turned on or off. That's 1 or 0. That's how all your emails, cat videos, and spreadsheets get processed, just a long string of ones and zeros. Quantum computers use qubits, short for quantum bits. And here's when the magic happens. Imagine a coin. A bit is like flipping it once and seeing whether it lands on heads or tails. It's a clear choice. Heads is 1, tails is 0. That's how classical computers process information, in clear, defined states. A qubit, on the other hand, is like spinning the coin on its edge. While it is spinning, it isn't just heads or tails. It's actually a combination of both at the same time. It's only when we measure it, that is, when we stop the spin, that it falls into one of those two defined states. That ability to exist in multiple states at once is what we call superposition. This is part of what makes quantum computers so powerful. They can explore many possibilities at once instead of checking them one by one. But it gets even wilder. Let's say you spin 2 coins at the same time, and somehow, magically, they sync up. Every time one lands on heads, the other lands on tails, even if one is in Paris and the other one on Mars. No phone, no signal, just instant connection. This is a rough metaphor for entanglement, one of the strangest and most powerful quantum effects. In real quantum systems, 2 particles can become entangled in such a way that their states are deeply linked. When you measure one, the other instantly knows what state to be in, even if they are light years apart. Some scientists call this spooky action at a distance. This means quantum computers can use entangled qubits to perform calculations that involve many variables at once, increasing their power and speed dramatically compared to classical computers. So these two ideas, superposition and entanglement, are what give quantum computers their superpowers. Now you might be thinking, cool science, but what does this mean for medicine? Let's take drug discovery. Right now, simulating how a drug interacts with the human body is incredibly complex. Every molecule, every protein has tons of atoms. Modeling all their interactions takes insane amounts of computing power. Classical computers try to approximate this. It's like building a Lego version of a brain. Useful, but not quite the real thing. Quantum computers, however, don't need to approximate. Because the building blocks of molecules, atoms and subatomic particles, naturally follow the rules of quantum mechanics, quantum computers can simulate them directly. In other words, they sort of speak the same language as the molecules that they are trying to understand. That makes them incredibly well suited for molecular simulation. In practical terms, imagine trying to predict how a new drug might interact with every cell in your body. Classical computers can make educated guesses, but it's slow and not always accurate. Quantum computers could simulate all the atomic interactions of a drug and protein in full detail, considering thousands of variables at once. This could help us design better drugs faster, predict side effects with greater accuracy, and even develop truly personalized treatments based on your unique genetic makeup. And here's where quantum computing makes it very powerful. Because quantum computers can process incredibly complex simulations at a molecular level, they could make these digital twins far more accurate and useful. It means we could develop treatment faster, avoid unnecessary risks, and personalize medicine for each individual like never before. But let's clear a common misunderstanding. Quantum computers are not just fast versions of your laptops and phones we use every day. They're not made to stream videos faster on Netflix or help you design your next PowerPoint. In fact, for most everyday tasks, your regular computer is still the best tool for your job. Quantum computers shine in a completely different category: complex problem solving, which involve massive amounts of variables and probabilities. That includes things like simulated molecules, optimizing large systems like hospitals, or factoring enormous numbers that are nearly impossible for classical computers to crack. So no, you won't be using a quantum laptop anytime soon. But for specialized tasks in medicine, logistics, and security, they're already rewriting the rules. So are we there yet, or is this still science fiction? Let's ground this in reality. Quantum computers today have made significant progress but are still in the early stages of development. While they're no longer confined solely to research labs, they are far from being consumer-ready. These machines require ultra-stable environments and temperatures close to absolute zero to function properly, which means they're still housed in specialized facilities. However, there is exciting news. You don't need to own one to use one. Thanks to cloud-based platforms, access to quantum computing is becoming democratized. Companies like IBM, Google, or Amazon offer remote access to real quantum processors. These services allow researchers, startups, and innovators in healthcare and beyond to begin experimenting with quantum algorithms and applications today. So while quantum computers aren't still in your living room, the tools to explore their potential are already at your fingertips. So there you have it. Quantum computing is still in its early days, but it is not science fiction. It's science just ahead of its time. Whether it is decoding complex diseases, simulating entire human bodies, or protecting your health data, quantum is poised to transform healthcare as profoundly as the microscope once did. So that's it for today. Thank you so much for listening, and I will see you soon for another tech adventure in healthcare.